Hello, this is the first video of a series where I will explain how to use a simulation model for addressing or to manage in a better way a Kanban system, a production system which is organized and managed according to the Kanban philosophy. We will be working with a system which consists of 4 workstations from 1 to 4, and this system works as follows. We will represent Kanban cards, which is a synonym. Kanban means the same as card, with green rectangles, and we will represent articles with brown circles. So the process works as follows. We have a warehouse or a stock corresponding to final product, which will be available for customers to withdraw whenever they arrive, and which way we will be able to satisfy their demand. We will assume that customers arrive one at a time, and they demand only one article. So we see that we have products here that have attached a Kanban. So when a customer arrives here, he or she will remove and get one of these articles, and the card will travel back to a place which is the Kanban board, where we have stored several Kanban, which means we have to produce as many articles as the Kanban cards indicates. Sometimes, or the usual thing is that we don't produce one single entity or one single article per Kanban, we produce several ones, but we will make a simplification here. So every Kanban will represent in order to produce one single product. So if the customer, as we said, removes one article, the Kanban will go back to the Kanban board. And this means that we have to produce a unit of final product to be sent to the final warehouse for another customers when they arrive. So for a workstation to produce, 3 conditions should be met. First, we have to find some Kanban in our board. Second, there must be some final product of the previous station, which is our raw material, seen as part of workstation 4. And workstation 4 should be available. It should be idle and available, ready to process this product which has been produced previously in workstation 3. So I'll repeat. First, we need Kanban, we need product to be processed in the previous station, in the final stock of the previous station, and we need to have the workstation available to produce. If those 3 conditions are met, we will remove one unit of stock from this stock, and we will start processing that to replenish this final stock. And the same thing occurs here. If workstation withdraws one article, the Kanban will travel back to the Kanban board of workstation 3, and the same thing will happen across all workstations till the first one. And we have a simplification here. We will assume that we have an infinite supply of raw materials. So whenever we have a Kanban here in our board for workstation 1, the moment this workstation is available, because it finishes producing this entity, we will assume there's another piece of raw material to start the process for the system. That is the way how, when a customer withdraws articles from the final stock, the Kanbans will travel backwards, upstream if you want, and they will represent production orders. But we will only produce if there is stock available from the previous station and the workstation becomes idle. So we don't overproduce stock. And we have here a table with the times for processing a single unit in every station. We have a triangular distribution with the parameters 50, 60, and 65. Workstation 2 takes from 70 to 80 minutes to produce an entity, and the third one is the slowest one because it produces on average one entity, one product every 2 hours. Varies variable, ranging from 110 minutes to 130. And the last station is probably something, an automatic workstation, and you always have a production time of 60 minutes. So as I said, we have workstation. We will assume that we have the stock cost of 2 euros per hour. So every time every hour we have a unit there, no matter what state of the process. We will be assuming a cost, a financial cost, or whatever cost we have, but it's all refers, or it can be summed up in a €2 cost per hour and per article. Every time we sell an article, we earn €100, and we will assume that we have a demand corresponding to customers arriving on average every 1 hour and 10 minutes, 70 minutes on average, and they demand every time arrive just one article. And we will assume we have one article per container, which means that the production size of an order is just one article, and we have the processing times we commented on here. And we will do the calculation of what is expected in terms of the number of cards we have to produce. There are several expressions, but we have this one here, which is the number of Kanban in every station. Is this fraction where we have the demand, the lead time, safety coefficient, this alpha here, and the articles per bin. So I will explain in the next video how to calculate these theoretical values, and then we'll check with the simulation model if this works fine or not.